Assalamu alaikum. Before I go to the next topic, I want to discuss this example. There we find the signal voltage at base, which is VB, V small b. There R1, R2, and RE, which is the base meter resistance, is parallel. So we add it by using only one thing. What is R in base? R in total, sorry, R in total. As a meter resistance is by using this formula. We read it before. IE is 3.8 milliampere and equal to the RE tunnel resistance is this one. So R in base is equal to 1.05 kilo ohm, which is represented this. This is R in base. So as three resistance are parallel, so the total resistance become equal to 873 ohm. Then this 873 ohm resistance is parallel to the RS. So we can calculate it and multiply by the source voltage, and we get the VB, voltage at base. There he show the result of this our VB, that the input voltage, which is about 10 millivolt on our signal, is greater than 7.44 millivolt due to this small RE resistance. This is everything is based on this. We calculated in next topics what affects on RE on the other things. There it is equal, symbol of equal, that's it come back. Okay, next topic is voltage gain. In voltage gain, this is the circuit diagram. The voltage gain is about the output voltage divided by input voltage. Output voltage, as we know, VC, and input voltage is about VB. So we calculate VC from the ground every time, and VB is also from the ground. Most of our voltage is counting by symbol by using ground to the that point, like this one and this one. As we know, VC is alpha AC IE RC. Alpha AC is equal to 1, then it nearly equal to 1, then it will be equal to IERC, where VB is IERE. We know that by putting this value in the equation, and we get the voltage gain of common emitter amplifier. There it depends mostly in RE prime. Alternation is that reduces the signal voltage, and voltage gain is less than 1. It gives the example for this. Suppose we give input voltage about 10 millivolt and our signal. Then the load resistance is result in 2.2 millivolt output signal. In this case, the alternation is about 10 divided by 2 is equal to 5, and input signal reduces about 5 factor because we get only 5 half, so it gives the half of it. There the alternation is Vs over Vb. It gives the diagram also. This is our overall voltage from this point to the collector point Vc. This is our alternation points at this stage, and from this point to the collector point the voltage gain, which is equal to this. Overall gain is multiplication of alternation and voltage gain, and we get the result Vc over Vs. Vc is a collector voltage and Vs is the input voltage. Now we discuss the bypass capacitor of the voltage gain. What affects the bypass capacitor? Xc is the capacitor resistance, and it is smaller than Re for good result. As we know that the maximum voltage gain is Rc over Re prime. The bypass capacitor C2 is act as a short circuit for AC, or the capacitor C2 do not affect on signal on AC. We discuss this example for more understanding. There we want to operate the input signal at 200 Hz to 10 kHz, while we use the capacitor for bypass or bypass capacitor C2, or we find the minimum value of bypass capacitor. For this we know that Xc is equal to Re divided by 10 in our previous formula by using this equation. So we get 56 ohm. When we put this resistance into the equation, we get 14.2 ohm microfarad. 14.2 microfarad. This is the minimum value of bypass capacitor for using at 200 to 10 kilohertz. Next is voltage gain without bypass capacitor. If we do not use the bypass capacitor, that means the AC input is not short circuit. Then Re is added to the in with Re prime. So Re prime can be added in Re, and this will be happening, and our voltage gain is more decreases as compared to the our bypass capacitor. So we get the result more accurately if we use the bypass capacitor. If we do not use bypass capacitor, then our voltage gain drops. There it gives the example. The what happen when we do not use bypass capacitor. In previous example, R is about 6.58. On the other hand, RE capital is about 560. We use the diagram 6.16 R slash 16, this one. But in this diagram, we do not use C2 capacitor or bypass capacitor. Then RE plus RE, these both resistances add up, and our result is about 1.76. With C2 the gain, अगर हम if we use C2, then this is about 152. The bypass capacitor is give the huge difference between the voltage gain. You can see it by analysis the example. Now the effect of load resistance on the voltage gain. Load is the current drawn from output amplifier at the load resistance RL, while RL is parallel to the RC, like this one. At AC signal, VCC act as a ground, so RC is parallel to the RL. Then we calculate R small c, because we use as AC collector resistance are used at AC current or signal. Then we get this result. So capital R replaced by small r, and this will be the our voltage gain. As small r RC, small r RC is less than this DC collector resistance, so the voltage gain is reduced. If RL, this one, is very greater to RC, this one, then this RC is nearly equal to the ACRC. Then voltage gain is very slightly affected. It gives the example for this to understand what happened with the voltage gain at R small c or RC at AC input signal. You can read it by yourself. Now the stability of voltage gain. Stability of voltage gain depend upon RE. As RE is less, the voltage gain is high. On the other hand, you can know if RE is greater, then voltage gain is reduced, and this RE is also depend upon this one. We also discuss this equation in previous topics. So in AC voltage, then RE increase, then voltage gain is decreases. If If we do not use the bypass capacitor, then equation become this one, because Re add by Re resistance, and this will be more reduces the voltage gain. We use a method swapping. What this is method? We divide Re into two form by using the bypass capacitor also. So our voltage gain is depend upon this Re1 only, and our equation becomes this one, because Re1, if Re1 is more than 10 times more than Re prime, then this Re prime can be neglected, and we get the equation in this form. Again, it gives the example to understand what happen when we divide these two resistance. Now we discuss what effects on the amplifier input resistance. R in base is equal to beta AC Re prime plus Re1. Now we add these two resistance and multiply by beta AC, and we get R in base, the total base resistance. This example gives us everything. Determine the DC voltage gain, AC voltage gain, total voltage waveform, and total output voltage waveform. If we remember all the topics previous about this, then we can calculate, or we can easily calculate this and understand the example of this topic. There it can completely express everything what happened. First he discussed the DC voltage gain. There he can calculate everything: RTH, VTH, IE, IC, IB, VE, VB, VC. We calculate these three voltage: current IC, IE, RTH or VTH. Next, AC signal. For AC signal, we calculate RE, R in total, R in base, then alternation, RC, voltage gain, and overall voltage gain, and all of this. This is our waveform. It also expresses what happen when we amplify the circuits. Now current gain. This is the simple current gain is in output current divided by input current. Input current is IC, output current is input current is IS, and output current is IC. There it tells us current IS, that's IS is the input current which passes through the circuit and reach at VB point, at this point or this point. There R1 and R2 is parallel, so it divides into two parts, I base and IB. I base is depend upon R1 and R2 or IB pass through the circuit to the transistor, and IS is equal to Vs over Rs into R in total. R in total is represented this one, the resistance from this point to the ground. So R in total plus Rs, which is also parallel. Power gain. Power gain is a multiplication of overall voltage gain multiplied by current gain, and we get the power gain. Simple.